In spite of the great advances in the field of mechanics, the internal combustion engine used in automobiles is still very inefficient. Much of the energy released by combustion is lost in the form of heat. Exhaust gases are released at high temperature into the atmosphere, and another portion of the energy is used in the car's electrical system. Excess heat in the engine block has to be taken away by a cooling system which transfers it to the surrounding air, leaving only 25 to 50% of the total energy to be used for moving the vehicle. The most popular cooling system uses water as a heat transfer medium from the engine block, which is usually aluminum, to an aluminum radiator attached to the engine and consisting of many small tubes equipped with a honeycomb of fins to convect heat rapidly, and an electric fan that blows air between the tubes of the radiator. This system works very acceptably in ideal conditions. However, it has the disadvantage that in seasons and areas where the temperatures drop to the freezing point of water, 0 degrees Celsius, 32 Fahrenheit, the water freezes, becoming a solid, and cannot work as a means of heat transfer. This is serious, but the worst thing is that the water, in case the temperature goes as low as 4 degrees centigrade below 0, 24 Fahrenheit, water increases its volume while in the solid state, thereby destroying both the radiator and the motor block. On the other hand, when the water temperature goes higher than 100 degrees Celsius, water begins to boil if the system is not properly pressure tight. Water is quickly lost in the form of steam and fails to act as a cooling liquid. To solve these drawbacks, an additive, propylene glycol, which extends the range between freezing point and boiling point, is added to the water, tolerating from minus 37 degrees Celsius minus 34 Fahrenheit at low temperatures and 129 degrees Celsius 265 Fahrenheit at the other end. The water flows between the engine block and the radiator, controlled by means of a thermostat valve that remains closed and opens only when the engine temperature requires cooling. A centrifugal pump, generally driven by a belt activated by the motor itself, circulates the water to carry out the cooling. In lightweight engines, such as those in motorcycles and other small vehicles, as well as in aviation engines, cooling is done by means of an air stream flowing between fins attached directly to the engine block. This is the end of my short presentation. I hope it will be useful to you, and please subscribe to my channel.